All right, let's take up solutions to a test we had here. This is quadratic test word problems. And let's run through solutions for these here. So first question here, we've got a quadratic, which is modeling a football being kicked. They tell us in the question that h is the distance of the ball in meters and t is time in seconds. And we want to go ahead and answer a bunch of questions here. The first thing they ask is, at what height was the ball kicked? So again, to find the height the ball was kicked at, the initial time must be 0. So we're going to go ahead and let t equal 0. And if I let t equal 0 here, you end up just getting your y-intercept, which in this case is 15.9. So at 15.9 meters, that's the height the ball was kicked at. So obviously very high in this situation. So perhaps it's being kicked from a hill. So moving on here, we've got here, they're asking us for what is the max height of the ball and what time does that happen at. So again, when you're in standard form, we know that max height happens at negative b over 2a. So in this case here, my t value is going to be negative 29.4. That's my b value over 2 times a, which is 4.9. This comes up to be exactly 3. And just a note here, that was 29.4. I ended up getting here at 3 seconds. So max height happens at 3 seconds. And you go ahead and evaluate the quadratic when time equals 3, and we get the following. We get exactly 60 meters. So in this situation here, and we end up getting here 60 meters happens at 3 seconds. All right, moving on. In part C here, they ask you when does the ball hit the ground? Well, the ball hits the ground when your h value is 0. So we're going to go ahead and set h equal to 0 here and look to solve the following quadratic. First thing you want to do when you're solving this quadratic is we want to go ahead and multiply across by a minus sign. That's going to give us positive negative 29.4t and minus 15.9. So going ahead and doing our quadratic equation, we get the following. And you can see here I get 2 times. One is 6.5 seconds. The other time is inadmissible. This time is negative time. We're not going to include that. Where that's coming from here is take a look at a sketch of the situation here. So you'll notice here the ball is being kicked from a hill or some sort of a cliff or something that is 15.9 meters tall. We had gotten that in the question. It's going to go ahead, it's going to hit its max height, which we actually found the max height happens at the 3-second mark. That's going to be right on the axis of symmetry. And that happens when time is 3 seconds. We end up hitting our max height of 60 meters. And then that'll eventually hit the ground. So the time we're getting here, the 6.5 seconds, that represents the ball hitting the ground. The other time there, the negative 0.5, is if we extended this quadratic in the negative time, we would get the minus 0.5. And that's where that's coming from here. Notice again, if you take up your roots, add them up, divide by 2, we still get our axis of symmetry, just as we would before. So the ball hits the ground at 6.5 seconds. All right, let's take a look at the next part here. For part D, they want to know how long is the ball above 30 meters. So we're going to go ahead and set our quadratic equal to 30 here. And recall the original quadratic is negative 4.9 t squared plus 29.4 t plus 15.9. And again here, if we want to solve this quadratic, we're going to bring everything to one side and get rid of that minus sign as the leading coefficient, which will give us the following. End up getting here 0 equals 4.9 t squared minus 29.4 t plus 14.1. Then we're going to go ahead and do the discriminant and quadratic equation giving us. I end up getting 2 values here. I get 5.47 seconds and 0.53 seconds. So let's take a look at the diagram again. So what we have here is I have the line h equals 30. We found 2 values where this happens. This is going to happen at 0.53 seconds. And the next time this happens is at 5.47 seconds. So in terms of how long is the ball above 30 meters, you'll see that we're interested in this time right here. So to find that time, what you do is from here to here is going to be represented by 5.47 seconds. And then from here to here will be represented by 0.53 seconds. So by subtracting those times, our answer for this is going to be 5.47 minus the 0.53 seconds gives us our answer of approximately 4.94 seconds the ball is above 30 meters. Let's take a look at the next question. So for the next question here, we have a cliff diver jumping off of a cliff here, and the motion of this cliff diver to the water is measured by the following quadratic. H is measured in meters, T is measured in seconds, and we want to go ahead and answer the following problems here. Now the observation to make here, and the most important observation, is this is currently in vertex form. So because this is vertex form, I know I have a quadratic that does open downwards, right? And not only that, I know because it is in vertex form, I know the vertex, i.e. the peak of this quadratic, is at 1.5 and 101.5. So right away, question A becomes very easy. What time does max height happen at? Max height happens at 1.5 seconds. And what is the max height that is hit? The max height that is hit for this quadratic is 101.5 meters. So again, huge advantage when you are in vertex form. You've got that peak. In this case, because the quadratic opens downwards, it does hit a maximum value, and I have the axis of symmetry, i.e. the when does the max height happen, and then the y-coordinate is what is the max height, in this case 101.5. In part B here, they ask you when does the diver hit the water. When the diver hits the water here, you'll notice when the diver hits the water, I know that the height is 0. So I'm going to go ahead and set h equal to 0 for the following quadratic and solve. Doing so, we get the following. And you'll see here I get 2 times here. 1 time is inadmissible. This is negative time. We're not interested in that. And we're interested in the 6.05. So this question here, the cliff diver will hit the ground at 6.05 seconds. Let's take a look at the last problem here. So in the last problem here, we have Shani is building a vegetable garden here. So one side of this vegetable garden is against a barn here. So I can go ahead and label these as X's, these as Y's. I know that we have in the question 150 meters of fencing to work with. So I know that the perimeter of that fencing can be expressed as 2x plus y. I'm looking to maximize the area of this expression. That's x times y. Like we discussed, you can't maximize 2 variables. You can only maximize 1. So I'm going to go ahead and isolate for y. Give me 150 minus 2x. I'm going to sub that into this equation here. And now I can get rid of the y and change it to 150 minus 2x. Now what I've done is I've created for myself a quadratic. This quadratic opens downwards. I'm interested in the max. So I can see here that this has roots at 0, and the other root is going to be 150 minus 2x equaling 0, in which case x is going to equal 75. So I have 2 roots here. One root is 0, the other is 75. I want the middle. So the middle is 75 plus 0 divided by 2. And averaging this out, we end up getting here 37.5. So when x is 37.5, I'm going to have my max area. So if x is 37.5, we can sub this in to solve for y, giving us y equals 150 minus 2 times 37.5, and I get y equals, I end up getting here y equals 75. So therefore we know that these x values here must be 37.5 each, so we'll put in 37.5. Likewise, that's 37.5, and the y value must be 75. So here x is 37.5, y is 75. And the area here will be the product of 37.5 times 75, which is 2,812.5 square meters. All right, that concludes the solutions to this sample test.